The next topic, least common multiple. So similar to what we did with HCF, understanding word by word from right to left. That is, we start with understanding what is a multiple. So let's consider an example, then move across rather than understanding the definition per se, right? It's better to take an example and understand. So instead of 6 and 8, I'll take 6 and 4. It's much easier on the number line. So I'm going to explain LCM using number line. Okay. We'll start off with considering the M part, that is a multiple. Multiple of, we'll start off with multiple of 4. So what is a multiple of 4 in natural numbers? We'll start off with that. It is 1, 2, 3, 4. 4 is the first multiple of 4, right? Then 5, 6, 7, 5, 6, 7, 8, 9, 10, 11, 12. Is it not? Then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 32, and so on and so forth. So let us write that off. 4, 8, 12, 16, 20, 24, 28, and it continues. The next is multiple of 4, 6, sorry, multiple of 6. So we'll start off with 4, 5, 6. Then the next number is 12, 6, 12, then 18 over here, then 24, then 30, right? So it continues. So we have 6, 12, 18, 24, 30, 36. Then we have 42, so on and so forth. So this was your multiple. So what are the next word is common multiple. What is common between these two? Next we are looking at common multiple of 4 and 6. So we have over here common multiple of 4 and 6 is, first is 12, 24, 36. Okay, I don't have it over here. So here too 36, right? With 4 and 12, 4 and 6 we have 36 as one more common factor. So let's mark those here as well. We have 12, right? Then 24, then 36. Now let me write it here as well. 12, 24, 36. And then now we have our least common multiple. That is these are all the multiples and it goes to infinity. Which is the least among them? 12. Right? So LCM of 6 and 4 is 12. Again, here we can't use that method. We can't use in day-to-day maths, we can't use that method. We need a shortcut, and the one which I find easy for myself is this. If you guys have some other method, you can follow that. But again, whichever is faster, please do follow that. So 6 and 15, you have to find the LCM. So again, what you have to do is you have to take the common factor. In this case, it is 3. So the quotient is 2, and in this case 5. Now, when you look at numbers that are co-prime, right? They are co-prime, is it not? That's when you stop. And post that, you just have to write LCM to be product of not just 3 but also the one which is at the last, right? So 3 into 2 into 5. So we have 10, 30. Okay, so 30 is your LCM. See, one of the trick is to make sure that you have the LCM but not HCF, or you didn't make a mistake. One of the clues is the LCM will be always equal to or greater than the numbers that is given. It can be equal to one of the numbers, or it should be greater than both the numbers, right? That's how you get to know that the least common multiple is right. Again, you can tell if it's wrong, but to tell it's right, you need to do the math right. But obviously you can tell if by chance if you get an answer which is lesser than any one of the number, then that is not the LCM. It can be equal to one of it, but never lesser than it. Okay. The next question, 16 and 24. Again, you need not start with any prime number per se. You can go with anything. So here it looks to be 4 looks to be convenient. So 4 is 16, 6 4 is 24. That's correct. Then we have 2 looks to be convenient. 2 1s are 2 2s are 4, 2 3s are. These are co-prime. And thus we have your stop. And thus we have our answer. LCM of 16 and 24 is the product of 4, 2, 2 and 3. Again, you need not start with prime numbers or need not always have prime numbers. Doing this process, you can always go with any composite number as well. So the product over here is what? 8, 16, 48. So again, I have always segregate things which I'm teaching. So I always do that. So here we have finding LCM for 3 or more numbers. So we have 6, 15 and 35, for which we have to find the LCM. See, for 2, it's kind of straightforward. When we have 2 numbers to find the LCM, straightforward. For 3 or more numbers, there's a bit of condition that you need to satisfy. Till then, you won't be able to stop the process of division. Okay. So what is that condition? I'll explain. So let's start off with this problem. So 3, 2s are, 5s are. Oh, this, okay, actually I want to change this question to 36. I think I wrote by mistake. And this is 12. Right. So when you look at it, all of this 3 as a group of 3, the co-prime is their co-prime because their HCF is 1. But between themselves, HCF is not 1. Like 2 and 12, HCF is not 1. So this is not where you have to stop. You have to stop when each pair HCF is 1. Each pair are co-prime. In this case, 2 and 12 are not co-prime. Now 1 5, 1 6, 5 6, the pairs are co-prime, so we can end it over here. Again, you can't stop over here as 2 and 12, right, are not co-prime. The HCF between them is 2. This is a process in LCM. Okay. So again, if you understand the math behind it, then you will understand why is it so. I can't go to that part because again it will get too lengthy. I'm looking at the content and I don't want to make this part too lengthy, all of this. I just want to give enough information so that you guys understand up to a certain extent and are able to do the numericals. So I'm not going to the details, why is it so, but yes, HCF between any 2 pair, if it's not equal to 1, then you should not stop. And now we can stop over here. So now we have LCM between 6, 15 and 36 to be 3, 2, 5 and 6. Okay, so 3 and 6 is 18 and 5 2s are 10, so 180. Right, that's your LCM. Now we have 4 numbers over here, 50, 60, 80, 100. So the very obvious number is what? 2, right? No, 10. So we end up with 5, 6, 8 and 10. Then are they all co-prime? Yes, between themselves they are co-prime, but as a group they are co-prime, but as pairs they are not co-prime, right? 5 and 6 is co-prime, 5 and 8 is co-prime, 5 and 10 is not co-prime. So I'll take 5 and 10 and I end up with 1 into over here. But you guys will be like, sir, is it okay to just copy the other one? Yes. Again, this is a process. You need not think too much into it. So next is, again, you can tell, so I mean, there is already a 1, should we stop? No. You have to continue till the pairs have HCF to be 1. But here HCF between 6, 8 and 2 is 2. So you need not stop. This is 3, 4 and 1. Now you can stop as 3 and 4 are co-prime and all the other pair are co-prime, and therefore the LCM between the above set of numbers is what? Is 10 into 5 into 2 into 3 into 4. So be smart when you are multiplying. So I'll multiply this first, 10 into 10, then I'll multiply this to 100, then I'll multiply this separately, 12. So 1200. Is it not? Right? 1200 is a number which is divisible by all of this set of numbers. And the next subtopic is the LCM has one of the given number. The LCM can be one of the given number. So what does that mean? See, we have two numbers, is it not? And one of them can be the LCM in the group. So it can be so in the 3 numbers set as well, 4 number set as well. And here I have 2 number set, 12 and 60. So the obvious now is 12 itself. 12 ones are 12, 5s are. So they are co-prime. So we need to stop over here. Then the LCM. Therefore the LCM is what? LCM is product of 12 and 5, that is 60. And this is one of the numbers. Done. The next question is LCM between 15, 45 and 90. So we have 15, 45 and 90. And the LCM between them is, well, we'll start off with 5. So 5 3s are, 5 9s are, 5 18s are. Right? 5 18s are. And should we stop over here? No. 3, 9 and 18 have 3 as common. 3. This is 3 3s are, 3 6s are. Should we stop over here? No. 3 and 6 still have something common. So you have to be ending only when there is co-prime between themselves as well. So now we have the LCM between 15, 45 and 90 as 5, 3, 3 and 2. So again, be smart. 5 and 2 is 10, 3 and 3 is 9, 90 is your answer, and that was the topic. But one of them will be our LCM. Okay. Before we finish, there's a small topic before we finish. So we're almost done. And the last topic is when we have co-prime. This is quite important because the scenario is common. That is when we have co-prime numbers, the LCM is the product of all the given numbers. So let us start off with 2 pair. So 4 and 15 are co-prime. Right? They are co-prime. Therefore, LCM between 4 and 15 is product of that is 60. That's it. Done. Okay. Next we have LCM between 9 and 8. They two are co-prime. Therefore, LCM between 9 and 8 is, the product of 9 and 8 is what? 72, and thus we have 72 as the answer. Now we have three numbers. Okay, so here to internally, here is where the confusing part is for many. Between themselves, all pair, right? You need to check for all the pairs. Like in LCM, I told you before as well, we have to divide till the point there is no pair. But in this case too, not but in this case too, you have to check with regarding to all the pairs. So 25 and 12 co-prime, 25 and 7 co-prime, 12 and 7 co-prime, right? So all the pairs are co-prime. Therefore, LCM between 25, 12 and 7 is nothing but 25 into 12. I'm going to write it as 4 into 3 into 7. Why? Simple reason being 25 into 4 is 100, 21, 2100, simple. Okay. So whenever you get multiplication of big numbers, you have to be smart. Here I have a question wherein you guys again, by default, if I don't tell or not, every problem is something that you need to pause and do it yourself. I'm not going to repeat too many times because repeating that will make you bored, right? So I'm not going to repeatedly tell, but I would like everyone to try on their own. So here, let's check if they are co-prime. 9 and 11 is true. 11 and 15 is co-prime, true. 9 and 15 are not co-prime. So here you can't use whatever method we have used till now. Right? Just multiplying everything will not work over here. So we have to reduce it. 3 is the HCF. Reduced it. And now check again. 3, 11, 11, 5. 3 and 5 are all co-prime. Therefore, the LCM between 9, 11 and 15 is 3 into 3 into 11 into 5. Again, be smart. Check what multiplication is easy. Well, I feel 3, 3, 9, that is 45 into 11 is quite simple. 450, 495. Okay. See, 11 into 45, how to do is 10 into, see, this is what I did, 11 into 45. You can do it as 10 plus 1 into 45. Okay. Or, no, this is good enough for you guys. Yeah. Right. It's quite simple. 450 plus 45 is 495. And that's how we can multiply something fast. So finish the test and see to that you do it well. Okay. Again, see to that you learn the concept basics well. And there is no time limit for the test. Take aram se and be organized in your work. Okay. The next topic I think is fraction also. So I'll see you guys in the next topic. Do well in your test.